Okay, so let's jump right in with a question that sounds super simple, but trust me, it's not. Is the stuff all around us actually pure? You know what I'm talking about, right? You're in the grocery store, you pick up some milk, maybe some juice, and right there on the carton, big and bold, it says pure. But have you ever stopped to think about what that word really means? And this is where things get interesting. See, for you and me, pure just means, no weird stuff has been added. It's not adulterated. But for a scientist, their definition is way, way stricter. To them, pure means something is made of only one single type of particle. So let's dive into this huge misconception. And I'm telling you, you're never going to look at your morning cereal the same way again. Okay, here it is. That milk you thought was so pure, a scientist would tell you, nope, not even close. It's actually a mixture, a whole jumble of water, fat, proteins, you name it. And it's not just milk. Seawater, dirt, even the air we're breathing right now. To a scientist, all of it is just a big old mixture. Okay, so if almost everything around us isn't pure, then what is it? Well, that brings us to the world of mixtures. Let's get into it. The definition is actually pretty simple. A mixture is just something that has more than one kind of pure stuff in it. I like to think of it like a crowd of people. You've got all these different individuals, right? They're all in the same space, but they haven't, chemically fused into one giant megaperson. They're just mixed together. All right, so mixtures basically come in two flavors. First, there are the homogeneous ones. Homo means same, so everything is mixed up perfectly evenly, like when you dissolve salt in water, right? Every single drop is just as salty as the next. Then you have the heterogeneous ones. Hetero means different, and with these, you can totally see the different parts. The classic example is oil and water. They just don't mix uniformly. But wait, there's more. It actually gets even more specific than that. Inside this world of mixtures, there's this really cool spectrum we've got to explore. Okay, first on the list are solutions. These are your perfectly mixed, homogeneous mixtures. The particles in them are so tiny. We're talking smaller than a nanometer. You can't see them, they don't scatter light, and they will never settle to the bottom. It's a completely stable mix. Now, on the complete opposite end of that spectrum, you've got suspensions. Just picture muddy water. It's heterogeneous, and the particles are big enough that you can actually see them. They make the whole thing cloudy. And if you just let it sit for a while, all that gunk is going to sink right to the bottom. It's totally unstable. And then, smack dab in the middle, we have the trickster of the group, the colloid. And yep, this brings us right back to milk. A colloid is sneaky. It's technically heterogeneous, but its particles are just small enough that it looks totally uniform. They won't ever settle out, but, and this is the big giveaway, the particles are big enough to scatter a beam of light. So this chart really lays it all out, doesn't it? It all boils down to two things: how big the particles are and what they do. Solutions have tiny particles that stay mixed forever. Suspensions have big particles that settle out. And colloids are that weird in-between category. They look stable, but that light scattering trick totally gives them away. And yeah, that light test has a super cool name, the Tyndall effect. So if you shine a flashlight through salt water, a solution, the beam just goes straight through. But if you shine it through milk, a colloid, you can actually see the beam of light in the liquid. That's the Tyndall effect. And you've definitely seen this before. Ever seen those beautiful rays of sunlight cutting through a foggy forest? That's it. The fog is a colloid, and the tiny water droplets are scattering the sunlight. All right, so we've talked a ton about what isn't pure. So what finally is? What do scientists actually call a pure substance? Well, for starters, you've got elements. These are like the fundamental Lego bricks of the universe. We're talking about everything on the periodic table: gold, carbon, oxygen, you name it. You can't break an element down into anything simpler through a chemical reaction. Gold is just gold. That's it. The other kind of pure substance is a compound. This is what happens when you take those elemental Lego bricks and you chemically snap them together to build something new. The key phrases here are chemically combined and fixed proportion. Water, H2O, is the poster child for this. It is always two hydrogen atoms bonded to one oxygen atom. No exceptions. And this brings us to probably the most important distinction of all. What's the actual difference between just mixing stuff together versus creating a brand new compound? This little experiment with iron and sulfur explains it perfectly. Let's say you just take some iron filings and some yellow sulfur powder and stir them together. What you have is a mixture. The iron is still iron, the sulfur is still sulfur. In fact, you could pull the iron right back out with a magnet. But if you take that same mixture and heat it up, bam, a chemical reaction happens. You create something new, iron sulfide. And guess what? It's not magnetic anymore. It's a completely new substance with totally different properties. So here you have it, the ultimate comparison. A mixture is just a physical jumble. The parts are just hanging out together, they keep their own identities, and you can usually separate them pretty easily. A compound, on the other hand, is a whole new thing. It's born from a chemical reaction, it has its own unique properties, and it has a strict recipe. Think about it, you can't just unbake a cake, right? It's the same idea, you can't easily undo a compound. And just like that, we're back where we started. We began with a simple word on a milk carton and traveled all the way down to the basic building blocks of matter itself. So the next time you're at the store and you see that word pure, you'll know exactly what's going on from a scientific point of view. It makes you think, doesn't it? What does pure really mean to you now?